Morning everyone, I am Simran Surve, a computer engineering student. The title of our project is The Flow Rate of Blood. My team members are Harsh Shailesh Shah, Rutuja Uttam Kore and Arpita Jagdish Patil. Our scientific advisor is Dr. Avinash J. Kamble. We all come from Pillai HOC, College of Engineering and Technology, Rasayani, Panvel, Maharashtra, India. Beginning with the abstract of our presentation. Mathematical biology is an interdisciplinary area that uses mathematical techniques and tools to model natural and biological processes. It is a field that applies mathematical concepts in biology. Calculus, broadly classified as differential and integral calculus, plays a vital role in mathematical biology to explore the biological phenomena. Many systems and processes are studied majorly with the help of calculus. The flow rate of blood in a blood vessel by using POISEUILLE'S law are discussed by means of integral calculus. We'll get a clear picture of how mathematics is applied in biology. The measurement of blood flow provides vital and essential information about diagnosis of various diseases due to any blood flow disorders. Therefore, integral calculus gives us a way of calculating such an important biological quantity. Here, I'll give a brief introduction about the presentation. When we talk about life, the flow of blood through our heart is the main reason we are able to experience this beautiful world. It is all the functions of our body are performed smoothly due to blood flow. Mathematical biology is a field that aims at using techniques and tools to perform mathematics, both theoretical and practical research in biological field, especially in determining changes and rates. There is also a field in biology called biocalculus that applies calculus for solving many problems. Blood is made of plasma, red blood cells, white blood cells, platelets, antibodies, and hormones. It is the fuel for our body. Considering blood vessel as a hollow cylinder and applying concepts of POISEUILLE'S law form the basics of this study. Here, I'll give a brief idea about what the flow rate of blood is. The flow rate of blood is the volume of blood flowing through a specific area in the vessel during a period of time. It is also called as blood flow velocity. Knowing or calculating the flow rate of blood is necessary during pregnancy and also for the prevention of first stroke in children. The flow rate of blood should be normal in everyone's body. Abnormal flow rate of blood causes sleep disorders, stress, and cardiovascular disorders. Medicine experts also prefer calculating blood flow rate before performing any surgery. Fluctuating flow rate is the reason for respiratory disorders in many premature ventilated infants. Flow rate of blood is essential for calculating cardiac output, which gives us the amount of blood pumped by the heart. Moving ahead with the mathematical idea. For any operation in mathematics, there is always an inverse operation. For example, addition has subtraction, multiplication has division. Matrices also have inverse matrices. Similarly, for the process of differentiation, the inverse process is defined as integration. Integration forms the mathematical idea of our project. Integration is one of the two main operations of calculus, other being differentiation. Integral calculus deals with total size of volume, such as lengths, areas, and volumes. For example, integrating a velocity function yields a distance function. In mathematics, integral assigns numbers to functions in a way that can describe displacement, area, volume, and other concepts that arise by combining infinitesimal data. Integration are used extensively in many areas. For example, in probability theory, they are used to find random probability of random variables that are around any interval. This is the representation definite integral. It is the fundamental theorem of calculus that connects differentiation with definite integral. If small f is a real valued continuous function over interval a comma b and capital F is the known integration, then the definite integral of f is given as following. From the beginning, we frequently heard about Poiseuille's law. So let's have a look at exactly what it is. Poiseuille's law is a fluid dynamics concept which gives the flow rate of a fluid. The main applications of Poiseuille's law include flow rate of blood or calculating flow rate of a fluid flowing through a pipe. This law states that the flow rate of a liquid flowing through a capillary is directly proportional to the pressure of the liquid and the fourth part of the radius of the capillary, and is inversely proportional to the viscosity of the liquid and the length of the capillary. This is the equation for Poiseuille's law. We will derive this equation in upcoming slides, which will give us the flow rate of blood. Let's understand what exactly flow rate is. Flow rate Q is defined to be the volume of fluid passing by some location in an area during a period of time t. In symbols, this can be written as Q is equals to V by T, where V is the amount of fluid and T is the time period. From this diagram, we consider a cylindrical area. The area of the cylindrical is A and the length is D. The volume of the cylinder is given as A into D and the average velocity is D by T, so that the flow rate can be written as Q is equals to A into D by T, that is A into V. So by this, we can say that flow rate is a multiplication of area and velocity. Let's have a look at law of laminar flow. Laminar flow is a type of fluid flow characterized by the smooth flow of the fluid in layers that do not mix. Each layer of the fluid moves with different velocity smoothly past the adjacent layers with little or no mixing. Laminar flow occurs due to friction of layers in the fluid. Typical examples of laminar flow include flow of honey or any thick liquid from a bottle. To better understand laminar flow, try simultaneously dropping two sticks in flowing river, one near the edge of the river and other in the middle of the river, and try to observe which stick flows faster. Yes, you will notice that the stick in the middle flows faster than the stick near the edge. The reason behind this is water flows in layers and the layer in the middle has the highest velocity than the layer near the edge. This is the reason why the stick in the middle flows faster than the stick near the edge. Moving ahead with the derivation, consider a vein in the shape of hollow cylinder with blood flowing through it. From the diagram, Q is the flow rate of blood, R is the radius of the vein, L is length of the vein, P1 and P2 are the pressures at both ends of the vein, eta is the viscosity of blood, that is the flowing ability of blood. And now, as we know that liquid flows in layers. Same is with blood. Blood also flows with layers. The layer near the middle has the greatest velocity than the layer near the edge. This is the reason why we need to apply integration. We calculate flow rate at a point which is at distance r from the center and then integrate this flow rate to get the total flow rate of blood. This is the main idea behind calculating flow rate. The law of laminar flow gives the velocity of blood flow in an artery. From this law, we get V is equals to P r square minus r square upon 4 eta L, where P is the difference between pressures, that is P1 minus P2. Here, we multiply velocity with area of ring 2 pi r to get flow rate Q at a given point. The area is considered as 2 pi r because it is assumed that only the ring of the vein applies pressure on the blood. The total flow rate of blood can be found by integrating the flow rate at a point at domain of 0, r, which gives us the following equation. Domain 0, r is applied because the radius of the vein can be 0 when the vein is completely contracted, and it can be maximum r when the vein is completely dilated. This equation is solved by using rules of integration. Applying integration step by step and solving all the steps, we get the final equation, which is the equation for flow rate of blood. Q is equals to pi p r raised to 4 upon 8 eta L. This is also the equation for Poiseuille's law that we saw in the earlier slides. At the end of the presentation, we come some to conclusions. Integral calculus is used to derive Poiseuille's law that gives the flow rate of blood. It gives a clear picture of how mathematics is applied in biology. The measurement of blood flow rate provides vital and essential information for diagnosis of various diseases due to any blood factors. Abnormalities in flow rate are very harmful to the body. Calculating the flow rate of blood is necessary during surgeries, dialysis, clinical liver transplantations, etc. Flow rate measurement can be beneficial in developing new health equipments in future. We successfully studied that integral calculus has been applied widely in biological field, especially in determining changes and rates. This is a list of references that we used for our presentation.